This is problem number 3 on the practice final, and it is sketch the phase diagram for carbon dioxide. Label phases, triple point, critical point, illustrate fusion, vaporization, and deposition. And the main salient features that we're going to have to keep track of here is start, come out to the triple point, and come out here, and then now if it was water, I would have a slope that goes this way. But with carbon dioxide, I'm going to have a positive slope. So I'm going to even exaggerate that. That one looks positive, but I'm going to even exaggerate a little bit more because this is the main feature I'm going to be looking for on the test. With carbon dioxide, it has a positive slope for the region between, this is the solid, this is the liquid, this is the gas. And so, if it was water, it would have a negative slope. It would be going up that way. That's why you can ice skate. That's why glaciers move. You could not ice skate. You could skate on dry ice, which is solid CO2, but you would design your skates differently. You wouldn't go off a blade. With dry ice, you'd have a flat skate that would have a huge surface area, and you'd be skating along on a thin layer of gas from the subliming dry ice, and you'd suffocate from no oxygen. But if you wanted to, when you skate on water, solid water, ice, because the slope of this line is negative, as you increase the pressure, you lower the temperature at which the melting occurs. And so you're actually sliding along on a thin layer of water that freezes as soon as you pass over it. So that's why you have all your weight placed on that blade. And that's why the glaciers can move, because there's a huge mass of ice pushing down on what few glaciers there are left, pushing down on the rocks, and that creates, that lowers the melting point, and it slides along on a little layer of water. So this is one feature that I'm going to want you to carry on. And now I want to label the phases, so I can do that with S for solid, L for liquid, and G for gas. And now I want to label the triple point, and that would be, I'll just do that with I'll have a 1, put a little arrow and all that, 1, and 2 for the critical point. And then illustrate fusion. And fusion is when we go from the solid to the liquid. So I'll have that with an arrow, which I will have as a 3. And vaporization, which is when we go from the liquid state to the gas phase. So that I'll put a little arrow, put a 4 around that. And then deposition. Deposition is the opposite of sublimation, or the reverse of sublimation. So I'm going to have an arrow going from the gas phase to the solid phase, and I'll put a 5 here. And then I'll put a legend over here where I go 1 is a triple point. Triple point, you'll recall, is the point where solid, liquid, and gas phases all coexist at the same time. It's the temperature and pressure where all 3 phases coexist. And number 2 is the critical point. And the critical point point is beyond that, this is the point where the meniscus disappears between the liquid and the gas phase. So beyond that, we have supercritical fluids, and it's very interesting behavior observed there. So I've got triple point. 3 is fusion. Which is the melting, okay, another word for melting the solid. 4 is the vaporization. And 5 is deposition. So this is just one way of doing it, and rather than writing all these out there on the diagram, I think it's a little clearer if we just use these types of labels with the numbers and a legend on the side. But any way that unambiguously labels things, it has, and unambiguous is the key on the test. You know you're going to get one of these phase diagrams is probably going to be water or carbon dioxide. So the main feature that I want you to be able to take into account, if there is a distinction, is the slope of this line. The liquid is the line between the solid and the liquid. And that's what you're going to have to make sure that it has a positive slope if it's CO2 and a negative slope if it's water, and exaggerated. This is not obviously to scale, but it carries the same features. So that's all you need to know.